All right, y'all. The last video that I'm going to be making for the Alex Homework 1 review um, is about union and intersection. So, union and intersection, these are operations that you perform on sets of numbers. So, a set is a list of a bunch of numbers or things, and a union and an intersection are operations that you use to combine two sets. So to combine two sets using a union, the way that you're going to do that is you're going to include, sorry, I gotta get myself ready here. Okay, so for the union, you're going to include any number or item in either set. So basically, if it's in one of the sets, it's in the union of those two sets. Um, and the way that you notate this, the notation that you'll use is A union B. It's like a little U um, between the two sets, and that stands for union. You would read this as A union B, and it would be the set containing all the elements of A and all of the elements of B kind of put together in one. I kind of like to think about this. A marriage is a union, and so these two sets are getting married, and they're just going to take all their stuff and they're just going to shove it into one house because they're now married, they're living under one roof, they're going to bring all their stuff with them. Um, and when you union two sets, if both sets contain the same number or item, you don't need to write it twice. So if A has a 1 in it and B also has a 1 in it, you only have to write 1 once in the set A union B. Hopefully this will make more sense when we get to solid concrete examples. But that's what the union means. It means you're going to take anything from both sets and just shove them into one set. And the intersection of two sets, you're only going to include the number or items, I'll say numbers or items, that are common to both sets at the same time. So you'll only include a number in the intersection if it is in both A and B. So we write this, the notation for this is A intersect B. Intersect is this upside down U here. And again, the intersection, it must be in both sets A by itself and in set B by itself to be included in the intersection. This is the overlap. That's another way to kind of think about that. It's the overlap between the two sets. And a union, I want to kind of mention here because this will be helpful. Union basically means or, and an intersection basically means and. If it's so in a union, if it is in A or B, it goes into the union. To be in the intersection, it has to be in both A and B. So the union means or, and the intersection means and. So that's basically what union and intersection mean. Let's actually practice this. Okay, so for the examples, we need to write both the sets A union B and A intersect B. If any set is empty, we will write this little guy, which is called the empty set. That is basically a set with no elements in it. Exactly how it sounds, the empty set. Okay, so let's do number 1 here. A is the set of numbers -1, 1, 3. And B is the list of numbers -2, 0, 2. So let's start with A union B. This is the union, which means anything that's in either set we're just putting these two things together. A and B are getting married. They're going to bring all their stuff and put them in one house together. So you can really list these in any order you want. I'm programmed to write them in increasing order. So I would start with the -2 that's in B, and then do the -1 that's in A, then the 0 from B, the 1 from A, the 2 from B, and the 3 from A. You could also just write these, and you could just take everything from A, the -1, 1, 3, and everything from B, the -2, 0, 2. Just put them in any order you want. But basically, everything from both sets in one giant set. They got married and brought all their stuff in one house. The intersection looks like A intersect B. And the things that are going to be in A intersect B will be the things that are common to both A and B. So we're going to look at our sets and say what's in both of these at the same time. And the answer here is nothing. There's no elements that are in both A and in B. So that means my intersection here is the empty set. There is nothing that's in both sets at the same time. So our intersection will be empty there. All right, so let's try number 2. This time, instead of just having a short list of numbers, here we have intervals of numbers. So number 2, A here is the set of all y values such that y is greater than or equal to 4. All right, so I'm going to put this on a number line so that I can see this. It's going to be anything greater than or equal to 4. So these are all of the numbers that are in A. B is the set of all numbers y such that y is less than 9. So B here looks like it's going to be an open circle at 9 and anything less than that. So here on the left, this number line is what the set A looks like, and this number line here on the right is what B looks like. So let's start thinking about A union B. What numbers are in either of these at the same time? So I often like to in order to figure this out, put both of these together on a number line. So 4 is here, 9 is here. So A is going to include all of this stuff. 9 is going to include from here over this way. And so anything that's covered by either of these lines is going to be everything. So the union of these two sets is actually going to be negative infinity to infinity. It's going to be all real numbers. This set A will cover everything above 9. It'll include 9 and anything above 9 that's not included in B. And set B here will include anything below 4 that's missing from that. So together they're going to cover everything. Their powers combined. And then A intersect B, these are the things that are only in both. So where do these two things overlap? I'm going to make a new number line here. The only places where we overlap here, 4 is common to both of these, so I'm going to put a closed dot at 4. Everything between 4 and 9 is double covered here, so I'm going to put a line here because all of this is covered by both sets. And then at 9, 9 is only included in set A. It's not included in set B, so I'm going to leave that as an open circle because it's not covered by both. So this is our intersection. It includes 4 and all of the things between 4 and 9, but does not include 9. So that is our intersection, the things that are covered by both sets. All right, number 3. Set A here is the set of all x such that x is less than or equal to 2. So again, I'm very visual. I like a number line. Less than or equal to 2. And here set B is going to be all values x such that x is greater than 5. So I'm going to have an open circle here and to the right. Okay, let's think about A union B. If I put both of these on a number line, I'm going to see what is covered by at least one of these things. So 2 is here, 5 is here. Okay, A union B is anything covered by any line at all. So these two don't overlap at all. So my union is actually just going to be negative infinity to 2, union 5 to infinity. Sorry, I didn't leave myself enough room there, so I'm sorry that's hard to read. But negative infinity to 2, closed bracket, union, parenthesis, 5 to infinity. So you're just write both of those together as a union. You just put them together. The intersection says what is double covered by these two things? And the answer is nothing. These two sets don't cover the same thing at all. So that again is going to be the empty set. And then finally, this last one here, number 4, A is the set of all the things less than 4. I'll put that on my number line. And B is anything greater than or equal to 6. So I'm going to do a closed dot at 6 and less than or equal to 6. Okay, so now to do A union B, I'm going to put both of these together on the same number line and see what is covered by at least one of these lines. So there's set A. Here's set B. So the things covered by at least one of these lines is anything less than or equal to 6. So it's negative infinity up to 6, which is actually the same as the set B. So A union B is equal to the set B. It's the exact same thing. And then A intersect B here. What is double covered? What is covered by both of these? Well, let's see here. I like to put this on another number line because we do have some things that are covered twice. So from here over, this is all covered by all of this stuff as well. So this is the part that's double covered here. So I know I'm going to have this part. Now the question is 4 going to be included in the intersection? Is it included in both? And the answer is no, because it's not included here in set A, which means it's not going to be included in the intersection. So the intersection of A and B is negative infinity to 4, and I'm going to not include 4, which is the same as the set A, which I think is interesting. Okay, so that is kind of a quick crash course in unions and intersections. I hope this was helpful. If you have any questions about homework 1 or anything thus far, please shoot me an email, and I hope you have a great day.